Hey everybody, and welcome to the February edition of Power Hour. I am Shane Singleton, and with me I have Nathan Irvin, product manager over the networking products line. Say hi, Nathan, if your mic's going to work here.
Yeah, good morning, everyone.
All right. So GoToWebinar has actually used a new interface, so I am familiarizing with that on the fly and getting my share back going here. So got a few slides for you today, and then we're actually excited to share a new product with you today. So we'll save that for Nathan though. No thunder stealing going on. All right. So you should be able to see that, Nate. If you want to confirm, that would be good, and we can just get started.
Yes, sir. Go right ahead.
All right. Thank you, sir. All right. That's my face. And like I said, I'm Shane. I'm the lead supervisor, manager of a sales engineering group. We're application engineers. Also, we help with a lot of support, and we get to do these power hours. And then, like I said, our networking product manager here with us today, special guest. All right.
All right. Can everybody see this screen all right? Right. The introduction to networking. So as he said, he's going to try and cover some of the basics. And Shane, we can hear you starting to come back in.
Thank
But we're
you.
going to talk through some of the basic networking models, the history of networking in general. And this is going to be pretty high level. This is meant to be an introductory session just to introduce some of the topics of basic networking and how they apply within a substation architecture. And then he'll go through some examples and we'll start to talk through some tools that you can use as you're building out a network and then, as he mentioned, we'll have a new product to introduce.
All right. So, what is networking in the simplest sense? We are connecting computers together. Okay. Yes, you can argue this is true with a serial cable as well, but you see here we have two computers that want to communicate, and we can do that. But what happens when you want to have more than two? Well, this guy here is either completely left out or these two have to disconnect so he can connect to one or the other. A brief history of networking, and I mean really brief. Initial implementations of this began in the 1960s and 1970s, though there were some earlier kind of isolated things. In the 60s and 70s, we began bringing in networks of networks, the internet as we might think of it today. You might have heard the term ARPANET. This was a defense budget funded network of networks. So different research institutions and such could get on the ARPANET, and they began developing protocols. So all computers, this is the other major part of networking, they have to be speaking a similar language that each other can understand. Doesn't matter if you're connected, if one is speaking Spanish and one is speaking something else, Afrikaans, something else. They're not able to communicate. So a regular system of bringing information together was required. And so they solved that. All right. Most networking presentations show you this stack of text. This is called the OSI model. That is the proper academic model. There's the TCP IP model, which is really so similar. We're just going to kind of use them interchangeably here. You can just see the two boxes in gray there. Those are grayed out because and again, I'm being general here. There's a lot you can go into here, but it's not important to understand the concepts. Those two are 5, 6, and 7 are kind of squished together in real practical implementation. Things of presentation, session, and application are just kind of handled together. Sometimes TCP IP also blends together layers 1 and 2, but we're going to keep them at this level for this presentation. Good. So as you move down, and I'm going to bring my cursor on, bad slide etiquette, but here's my cursor, it's my laser pointer. This is like an envelope. You put data in an envelope, your application. If it's in a substation, let's say it's DNP data encapsulated for this. So it's DNP data. Now let's move down the stack. These two don't matter because we don't use them that much. We get to the transport layer, we start talking about ports, and like TCP comes from here, the term TCP or UDP. This is making sure you reliably deliver the message. So now an envelope, this is the first envelope. Now we have a bigger envelope on top of the first envelope. Now let's jump down to layer 3. This is the network layer. This is where what we probably are mostly familiar with shows up. This is IP addresses. It's another envelope on top. We start talking about packets. If you want to sound a little bit smarter and you remember nothing else here, remember packets live on layer 3, frames live on layer 2. I'll come back to this later. And then ports live on layer 4, your data is at layer 7. So it's just kind of layers of envelopes. So now we're at the networking layer. We're 2 envelopes deep, but now we want to go yet deeper, because where do I send this physically? That is another envelope. It is the physical addressing. You've probably heard of MAC addresses before, maybe not. It's machine addresses. It's talking about the physical ports on an Ethernet switch. On this outer envelope, a normal Ethernet switch is just going to be looking at MAC addresses, and none of these look at layers above it unless they're fancy. So finally, the last envelope, these are just ones and zeros down a wire or fiber optic cable or airwaves too. So that's called encapsulation as we add the envelopes. But if we want to de-encapsulate it, you are opening envelopes. A switch only looks at the outer envelopes or envelopes to say, where do I send this message? It doesn't read inside unless, again, it's a higher enabled switch. The network layer just needs to know where on the network where I route this to. It's like an address for your house. Transport is more for reliable delivery, and there's certain things like that. They're ports, and then back up to application. We are opening envelopes just enough to get it to your computer from mine so you can open up this slide that I'm showing you right now. And the sound that you're hearing right now is coming at the application layer. It's largely HTTP type data, website stuff. All right, let's move on though. That's just kind of a show of what's going on in the stack, but we don't remember that. Don't worry, we're gonna keep going if it lets me. All right, so we needed some smart tools to get 2 computers connected together, more than 2 computers connected together. So the original play on this is, you might actually call it a layer 1 switch. It was just a physical bridge here, the hub. It would just take the wires in your Ethernet cable, your wires in your network cable, and it would just copy them to all the ports. So you had your wires come in, you would have a backplane that has all the wires, and if you had a message come from, I'm going to use my pointer again, a message come from this computer on the right here, he would come in and it would just broadcast out to everybody, literally and electrically, it's like a super wire. That's all it is, a hub. So that was great because we could connect multiple machines together, but it was also too stupid, because the more we start sending data across networks, just like you on a walkie-talkie, if 2 people talk at the same time, you can't hear either of you. So you have collisions. Also, they're super not private, let's say. Broadcast means that they're going to send something to everybody, even if this message from the left computer is really only for the top computer. The right computer hears it every time. So unsecure, and then I mentioned performance issues here. If you have packets colliding all the time, your reliability is terrible. So we are connected, and you used to be able to buy hubs, but we've moved away from them because they got issues. So if you have a hub, well, you might need it for some sort of testing of something if you want a port thing, but don't use a hub. Just throw it in the trash. Okay, so a hub, you could jokingly, affectionately call it like a layer 1 switch. You're just mirroring the stuff along copper. Okay, let's go to the next thing, because we got to solve this problem. This hub's stupid. All right, something less stupid that came out is a switch. A switch is a term. Intelligent bridge, I think, was another term for it when it was coming out. But the switch has intelligence. It keeps tables of what ports are connected to what. So after an initial message, you might have heard the term ARP before. If a message comes from computer on the left and it's destined for computer on the top, after the initial figuring out where everyone lives, the layer 2 switch, operate on layer 2, even an unmanaged switch, layer 2, will remember, hey, I saw a frame from left computer, it belonged to top computer, and it will assign in a table, I have left computer on port over here, this port, and I have right computer on, say, this port, and it will never broadcast a message again because it knows where that computer lives. The thing that it uses to address these are called MAC addresses. So every port will remember MAC addresses, layer 2, to route traffic. And what is good about this? Not only does it come with smiley faces, it also now addresses the messages, MAC addresses, layer 2. It also doesn't have collisions anymore, generally speaking. It works very, very well. And the performance is much higher. You're not losing messages. I should have listed here, it's secure or more secure. I'm not broadcasting messages to everybody. So you might be thinking, and you might actually be using this right now. What about Wi-Fi? What about Wi-Fi? I'm checking to make sure my audio is not terrible. Okay, good. Not terrible right now. Thank you, everybody. Yeah, so on Wi-Fi, we're going to talk about a Wi-Fi access point. Typically your Wi-Fi thing that you have from your internet service provider is a combination of a switch and a router and an access point. So we're going to talk about Wi-Fi access points. They operate a lot like a hub. They blast things to everywhere. And yes, there's some intelligence and some security built in, but when people say Wi-Fi is inherently less secure, that is almost axiomatically true. You can make Wi-Fi more secure, you can do things to try, but you're sending the message over the airwaves. You're just blasting it out there. So in a way, it's better than a hub, but in another way, if you're trying to be ultra secure, Wi-Fi is probably not your way of doing things. That's why we don't Wi-Fi in a substation. That among other reasons. Reliability is also really important. Okay, so this is the switch. The switch is awesome. Just remember, I'm trying to tell you something so you can walk away with something here. Your physical addressing goes on at layer 2. MAC addresses, frames, switch. Layer 2, MAC address, frame, switch. Those are all layered up there together. Okay. So now, sorry for the corny graphics here. This is what Visio had for me. What if we need a network of networks? Okay, so we are bumping up to layer 3 because we have to route things. So let's say that network 1 and network 2 are in different buildings, or they're across the country or across the world. Let's just say remotely located. You could get a really, 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 really long cable and plug them in. In fact, that is done. There's things called like Metro Ethernet where the ISP is in some way kind of doing this, but that's a more advanced discussion. In the theory here, the way that you connect two networks that are remotely located is through the internet and through a layer 3 appliance called a gateway or a router. Indeed, when you set up a IP address in one of these guys, if you're doing it manually, it asks you for a gateway. And so the gateway says, all right, I do not know. Well, the gateway tells it where to look to get to the internet. So let's go back to the switch here. Let's say there's a packet on the switch. Left computer wants to send a message to right computer. Bounces through the switch, all good. MAC addresses, that's great. But now let's say I want to ping this diagonal caddy corner switch some distance away, or computer distance away. Ping, I don't see it, I don't see it. Let's check the gateway. And the gateway says, hey, I'll check for you. The switch now remembers where the gateway is, by the way, by MAC address only, layer 2. Then this layer 3 device goes ping, you got it. The switch broadcasts out, hey, where you at? And then finally, this computer says, hey, that message was for me. So back to the switch, it's searching to go back to its gateway and then back out this way. The gateway enables you to route at layer 3. So we're talking IP addresses and packets. At layer 3, that enables that connection over distance. If we're talking envelopes again here, you might say the data link layer is like a street address. The network layer is more like a zip code, and that helps the post office get you to the right area. That's kind of a weak analogy. You could probably do better, but just remember we're different levels of addressing. The switches are layer 2. They don't open the envelopes up here usually. This gateway is layer 3, and it helps get that zip code to the right place and then let the switches do the work. So again, just to drill this, if you remember nothing else today, remember a switch operates at layer 2. It sends frames. That's the more outermost envelope that you're going to have before you just get to electricity. And then router sends packets and IP addresses and such at layer 3. We're kind of ignoring transport layer right now, but that's what we're going to do. I do see a question up here, and that is a good question. All right. Shannon asks, what is layer 2.5? And just to address that briefly, I think I'll give you a better answer later. To address that briefly, there are protocols. And also, what's a layer 3 switch? I love it. These are great questions. I'm glad we're asking. Layer 2.5 is the more complicated question so far. Layer 2.5, there are different ways that you might live here. There are things that you can do protocol-wise. One of them is called MPLS. And you can do things in MPLS, for instance, where it's multi-protocol label switching. This is getting way up here on the not basic stuff right now, but it allows you to operate between layers 2 and 3. That's one example. And then layer 2.5, where you might also.
Okay, it seems switching applications there might have caused that connection to stumble. So he's going to take a look at that. In terms of finishing the question, I think he was discussing kind of the differences between the layer 3 switch versus a router. Essentially, it comes down to a layer switch is kind of routing traffic between or within different LANs, so inter-VLAN routing as well as routing to different local area networks. It does use IP-based routing though, so that's why it's considered a layer 3, but it's more of a hardware-based switching versus a software-based WAN to LAN connection, which is where that router comes into play. So a little bit different. And there I hear Shane coming back on. Maybe not.
Yeah, does that sound okay?
Yeah, there you are.
Can you hear me? Okay.
Yep.
I'm going to talk to somebody about, I think it's actually the go-to dashboard that is struggling right now. So anyway, I'm really sorry about cutting out. Did you get through layer 3 in the substation? I mean, we can do it real brief.
Gave a high level, yeah, the difference between the router versus a layer 3 switch.
Yeah, yeah. And so like a layer 3 switch just needs to be able to do things with IP addresses. It is valuable, but often at the full like OT edge, you don't need that, because I just described for you a multi-layer switching stack that's kind of like getting into data center level stuff, and maybe your IT at your company is doing that. But for like just connecting IEDs and getting them to your gateway device in a substation, not so much. So we did follow through a substation network. I did take longer than my network took some time. So just briefly here, this relay would send me a DNP message, let's say. It's going to go through the switch. The switch already knows where the Orion is, or it would figure it out after a ping. The Orion reads the message, replies to the message, or vice versa. Maybe the Orion called it, and then replies back down to the relay. These relays might have protection, like a mirrored bits or a goose message or something going between them. So then it could go through the switch and back down out here. Like remembering the stacked envelopes, that's really still going on here. It's just that your application data isn't video, it's DNP or it's SEL or it's. All right. So the problem is we have different requirements for a substation network, where it's okay for your IT department to have a switch fail. They'll just throw a new one in and maybe they have a redundant one. When we're talking about substation or protection going through this, I don't want this going down at all. This has to be the most reliable thing that has a brain in my substation. Like you have to treat it kind of like a relay. And then when you really start thinking about it, it gets kind of scary. So you want a top end device handling this. That's why you went with the relay you chose. That's why you went with an RTU that has a good track record and that is stable and easy to work on, and redundant power supplies come into play. So how do we solve this in the substation? Focusing on reliability, you got to be secure, and it's got to be easy enough to use for somebody who doesn't do IT all the time. A lot of you people here are OT people, which there's some level of crossover, but again, your priorities in OT are different than they are in IT. And so you can play nice, but you need to design your network in OT and take ownership of it. All right, so here's some problem solving. You make a redundant network, so you have two switches. There are protocols to enable this. Your relays also have to support this, but let's just skip that for now. You need to be able to talk to two networks at once. That way, it's called PRP or HSR, Parallel Redundancy Protocol, or High Speed Ring, I think is one of the ways you explain HSR. There are topologies to be redundant, and so even if I lose one switch, I never drop a packet. Switches are kind of agnostic of each other depending on how you set it up. The switches do touch each other more, but the head device, or this could also be your gateway in this case, your upper level device is connected to both networks and you never lose a packet. That way your relays, which are also connected to both, never lose protection or coordination or SCADA control. So this is such a big deal in a substation, but it actually gets worse. So here is a trend that's emerging. You're not seeing it as much in the United States. It's actually very common in the other parts of the world. It lends itself to fresh builds, and we have such a built-out grid. That's why you're not seeing this in many places. But digitalization of the substation, yes, we have a microprocessor-based relay already, but it goes as far as being able to virtualize the relays. Let's talk about this architecture for a second. Kind of a side point, but it just demonstrates how intense networking is getting in the substation. So instead of being hardwired to your substation equipment, you have high-end analog to digital converters called merging units, and they take data from your substation equipment and they quantize it. I don't know, not quantize, that's something else, but they quantify it into a data stream and they put it on the network. So you might have amps A, amps B, amps C. Those are three data streams, and they are intense. Like they are dealing sub-cycle, so they're doing per cycle as much as like 80 samples per cycle right now in long analog data. So it's just a fire hose of data, and you're going to have 100 of those, in a substation or more data points. So then your switches are kind of like a transformer. You can't have them go down. You have no choice but to make them as reliable as possible, because if they go down, you can't do protection anymore. This will be to some level true in any architecture that uses a network switch, but extremely true here. Then in this one, we don't have physical relays. You still can in this architecture, but these are virtual relays on a server. So all the protection is happening in here. You've got to get data from these merging units and then like trip and close commands from through these merging units, through the switches, out of this server-based protection. And the network is everything in that case. Also, you do your timing through the network as well, as that's shown here. But now you have the switches, they have a very high data requirement. They've got a very high reliability requirement, not dropping a packet at all in any circumstance, even on a failover. If somebody hits one with a hammer, the other one just picks up, it's done, but you can keep going without dropping anything. And then also you've got to segment your networks, because that high data stream network, you don't want that segmented. And so you start getting into layer 2 smart layer 2 thing, a little more advanced, be accessing in this hardened switch in this architecture. Scary. You might have seen something like this before. This is a digital substation. You need a digital substation architecture to necessitate an awesome switch, but I'm going to go to the next slide and double check. Y'all still hear me? Okay.
Yeah, you are fading in and out there in the end of that. Yeah, but at this point, Shane, did you want to add anything additional, or I think we can go ahead and ask for questions on this initial section before we move on to introduce the product. So yeah, I think, does anyone have any questions on kind of the overall network architecture, what a digital substation looks like, any challenges you're facing, things like that? We'll open it up here for a second. Okay, I'm not seeing anything funnel in at the moment, so if you do, feel free to just put them into the question box there, and we will answer them as we continue on. We'll feedback. Okay, we did get one question regarding software-defined network on the switches. So At this stage, that is not something that we are considering. There's definitely some changes in the industry, and in general, networking as a whole is starting to adopt more and see some software-defined networking. There are limitations to some of the things you can do, and there are some. I would say it's early to bring that into the utility space for sure. There's challenges in regards to management of the switches and being kind of into a central location. They do have one management central point, and some concerns with how that essentially would be managed over time. And like Shane said, as we move more towards digital applications and the digitalization, it's very critical to ensure that a network does not go down or have any issues. So at
Yeah.
this stage, we are not necessarily looking at software-defined networking.
Yeah, just to riff off of that while I have my network here. Yeah, the software-defined networks, they have a lot of power. My joke with somebody is that they're a NERC, not like a layer 8 switch, because there's a level of oversight on top of everything. They are helping you that their main cell is helping you comply and prove things to NERC. They have like a print report button that shows every port going to every place. Largely, I find it's a compliance move, but when it comes to sheer reliability, they have some perks, but actually they would be considered less reliable due to central management. If you lose central management of your switch, or I guess I should say your SDN, you actually can run into issues and it's hard to bring back online. So there are trade-offs. If you are told that the SDN is the only way ever, it's complicated. It's not exactly what I mean by it's complicated is it is not the be all end all. It's a choice you make and there are trade-offs. So yeah, I was just reading about that the other day. I'm like, why wouldn't everyone do an SDN? And there are indeed reasons. Segregating responsibilities, higher reliability. Yeah, and then one other note about SDNs, it's like full Kool-Aid, all or nothing. Every switch in the network that you're dealing with, and I say switch lightly now because they don't act like switches anymore, has to be SDN. They all have to match. They all have to be centrally controlled by the same flow controller, it's called. And if you wanted to just bring one SDN online, you would struggle to do that. You have to overhaul your whole network. Whereas integrating managed switches, you could do bit by bit. You could do over time, and you also could have a migrate path in the future instead of having to change your whole network out. So migration over time is another downside. You are really putting yourself at the mercy of a vendor as well when you bring in SDNs. So anyway, they're cool. I like them, but it's not all gravy. There's always a trade-off in technology. Okay, Nathan, I'd say I beat that to death. You want to talk about something cool?
Yes, no problem. Thanks for speaking a little more clearly on the topic there. So, what we'd like to do now is introduce the exciting news for us. So, we have released actually it's available today the Hermes 2000, which is a layer 2 gigabit switch. So I don't want this to turn into strictly a sales pitch, but I just want to highlight some of the reasons for bringing the switch to market and some of the benefits that or key features to look out for when selecting a layer 2 switch. So as we notice this shift over the next 10, 15 years, visualization and networking is only going to continue to grow. As Shane talked about merging units and starting to get into some of those sampled value measurements, the data that needs to flow through these switches is significantly increased. And as such, making sure that you have the bandwidth to support that and the redundancy to support that is something key to keep in mind. The electric grid continues to evolve, substations are going to need to accommodate more and more of these smarter solutions. And so you want your network to be scalable in order to handle that increased demand. So Shane talked about all of the layers. We briefly touched on an unmanaged switch. It is different from a hub. As he pointed out, it still does live in that layer 2 space, just being unmanaged. It doesn't have all of the options for VLAN recognition and some of the redundancy protocols, and it does stick with more of the MAC addresses and setting up that table and using frames versus some of the packets. So that's where we start to get into that layer 2, where we can then interface with a layer 3 or a higher network as needed, or can shuffle between various VLANs and start to get into the packet space. So some of the key things as you look at a utility, and you need this to be what we would consider substation hardened. So finding a switch that can stand up to the harsher environment, as well as the Gigabit Ethernet, as we talked about, having that higher bandwidth. So the Hermes 2000 is a full gigabit switch, meaning all 28 ports, no matter what configuration. I'll show some of the configurations that we have, but it is a 28 port switch. And all 28 ports are full 10100 gigabit auto negotiating ports. So as you continue to increase that data flow, that becomes more and more important. 61850. So I want to make sure that there's a clear understanding of what the difference is 1850. So there's kind of two elements to that. A lot of times when people hear about 61850, they immediately think of the kind of the protocol standard and the communication standard. And while that is certainly supported, what we're focusing on here and trying to highlight is actually a hardware rating. So there is a EMC, vibration, environmental testing that in order to be classified as an IE or have the certification for IEC 61850, it requires a much higher level of compliance to some of these EMC events and the vibration, ensuring that no packets are lost. So there are two classes as well within that even. There's a class 1 and a class 2. And the class 2 means that in those EMC events or under the vibration, no packets are allowed to be dropped. And that's what the Hermes 2000 has rating for, is that class 2. And when we're talking about IEC 61850, we're specifically talking about the hardware, although it certainly will support the communications protocol as well. We do have a redundant power supply as well, so there's options for high voltage, low voltage, and the redundant power supplies. As I mentioned, all 28 ports are the full gigabit mix of RJ45 copper and SFPs. We also do have the USB micro console port and an SD card where you can actually copy a configuration. If you have specific configuration, you can copy it to that card, be able to quickly copy over those to a new or a replacement switch, or if you have a similar switch application, you could set up different substations in a similar manner. We talked about the power supply redundancy. There's a digital input and an alarm as well. Other key features to keep in mind when you're working within this digital substation application, you do want that PTP transparent clock functionality, VLAN support, so that you can start to segregate some of your networks, your traffic, and make sure that certain equipment, that helps with some of that NERC SIP compliance as well. So as you're needing to segregate things and kind of isolate some of the aspects of the network, that can all be done within a layer 2 managed switch, such as this. It is a relatively compact enclosure, fanless design. All of that also plays into that hardware rating that we talked about. And then the HSR PRP transparency. So you do have that redundancy protocol support. From an SFP standpoint, we do offer multiple options similar to the other products. So you'll see these as the same basic options that we have for the Orion and the Kronos products. So those are some of the key ones. Certainly you can try others. These ones have been tested, the ones that we offer, tested and guaranteed to work, but that doesn't mean some of the others out there may not work as well. And of course, it is backed by the NovaTech 10-year warranty. So as you consider adding this to the system, you still get that continued support and warranty. All right, it looks like
My turn.
I hid the slide by mistake that has some of the configuration options. So why don't you jump back in and I'll get that pulled together so that I can show that here shortly.
All right, I will attempt to share. Actually, yeah, leave that up because every time I try to share something, it seems like GoTo's dropping me. So, all right, so wanted to point y'all toward the customer community site. That is novatechautomation.com/community. Here's where you would find a recording of this power hour. Here's where you would be able to search and find some data sheets. You could find links to your latest software. And of course, as we want to know more about this Hermes 2000 product, you can also find things like manuals, updates, stuff like that in here. The next slide, this is support. So there's community and support. The two are kind of linked together, so don't sweat it if you're on one or the other, but you get access to these. A lot of good stuff in here. The support site is support.novatechautomation.com. That will give you kind of a streamlined dashboard for different firmwares, OS distros. You can get some documentation here as well as a management console for your different Orions. I say console, I just mean you have a record of which Orions are yours in here. And also something to keep in mind, we have file sharing utility here. So you can click My Files on the left. My Files on the left will allow you to send files to me that are maybe too large, or the email protocols are not allowing you to send an old something or other that's getting blocked. We can help you with there and communicate two directions. Stand by though, Hermes firmware stuff is headed that way, but right now you won't see it. You can get Orion, Bytronics, Kronos there as well. Next slide is the booking site. You actually can directly place time on my calendar and my team. So you see here, the group of us, we do have a couple Spanish speaking options as well, but you just select either anyone or the engineer you want to talk to. Say you wanted to talk to me, choose a date, and then it will real-time link to my calendar. So if I'm blocked out, you won't be able to click that time. But we can book a 30-minute session to talk about, let's say you're interested in the Kronos or the Hermes. Since we just talked about Hermes, let's talk about Hermes. We can see if it fits your application, or maybe you got one and you're trying to set it up. You call me. This is a way to help you set up a Teams meeting without having to figure out what was my email signature, etc. So definitely make use of this. We want to talk to you. Next slide, please. All right, actually, we're getting into the last slide. The question is, Nathan, do you have that configuration data in the last minute and a half handy?
Let me pull up a separate presentation table.
Yeah, no worries. Yeah, you can share just anything on your monitor if you need to as well. Definitely. One question, something you all can dump in the chat, actually. Just use the question portal. I do see some questions. We're getting to the end, so I'm going to have to apply to these. I'm going to have to reply to a lot of these separate. We're right at 11. I think you can close and share. So we're here to help. Yeah, but your configuration options should be popping up here. I see them.
Good, perfect. Yeah, so I'll just quickly touch on this. I know we are out of time, but there's basically two main configurations. One that has 24 copper ports and 4 SFP ports, and the other that has 12 copper ports and 16 SFP ports. So depending on whether or not you have higher fiber applications or the copper is sufficient, those are kind of the two main ones. And then you have a breakdown of high voltage or low voltage power supplies.
Awesome.
And all that is up on the website, so you can go look at it. The data sheets are posted. So if you do have any other questions, feel free to take a look there or reach out to us directly.
Yeah, definitely. If you're curious, request a demo unit. These things are super fun to just hold in your hands. It feels like the real deal. So, all right. Well, with that, though, I owe you a couple minutes on this. Thank you for bearing with us through our networking issues and the literal networking issues that we've solved. Thank you, Nate, for joining us. And I'm going to sign off now. Thank you all. Have a great day. And thanks for joining this Power Hour.
Yeah, thanks, everyone. If there were still open questions we didn't answer, we will have those and we will follow up with you.
Yes, sir. Thank you.